I'm Professor Nguyen. Welcome to chemistry. In this video, I would like to show you how to determine the bond polarity in a molecule and also determine the molecular polarity, that's the overall polarity of a molecule. A molecule has chemical bonds. Each bond connect two atoms together, okay? Electronegativity is the number between around zero point 0.7 to 4.0, which indicates the ability of an electron of an atom to attract the bonding electron, okay? So following are the few popular ones. Now, sodium is small, that means it doesn't attract electrons towards itself as much as hydrogen or nitrogen or fluorine is the highest one. That's what electronegativity means. Okay, so if carbon make a bond with oxygen, the electron in that bond is actually closer to oxygen because oxygen has higher numbers of electronegativity. Okay, now type of bonds. There are two different types. Okay, pretty much in terms of covalent. If you subtract the two numbers, that's called electronegativity difference, that's delta En. If you subtract them, and I always take the larger one minus smaller one, okay? If it come out from 0 to 0.4, the bond is nonpolar. If it come out more than 0.4, like 0.5, that's polar bond, covalent bond. Now, ionic is greater than 1.9, but you can also recognize that by ionic bond is between a metal and a non-metal. Okay. Now and that's a little tricky. I mean, sometimes that's also a coordination bond. Okay. So, but we're not going to go to that extreme for now. Okay. So let's do an example. NH bond. Nitrogen hydrogen bond. You look up nitrogen is 3.0, hydrogen 2.1. Take the larger electronegativity minus the smaller one, you get 0.9. And therefore, the bond is polar. NH bond is polar because it's more than 0.4. It's that simple, okay? You can try with CS bond. C, if you look it up, 2.5. S, I believe, is also 2.5. So you subtract them together, that's going to come out 0. So the bond is perfectly non-polar, CS bond. However, CCl bond, C is 2.5, Cl is 3.0, so the difference 3.0 minus 2.5, you get a 0.5. That's make it to the second, to the cutoff 0.4, so that bond is polar, it's 0.5, that's polar bond. And CBr, C is 2.5, Br, I believe is 2.8, so 2.8. So when you subtract, the difference is only 0.3. There is a difference, but it's not significant enough for the bond to be polar. Therefore, the CPR bond, we classify this as a non-polar covalent bond. Okay. Now, the molecular polarity is the whole molecule's polarity, and that's depends on the geometry of the molecules. Each bond polarity is like a vectors. And in a molecule, if all bond polarity cancel out, vector cancel out, then the whole molecule, also known as molecular polarity, is nonpolar. And if they don't cancel out, if one bond is different from the rest and it's polar, that molecule has to be polar. Okay. Um, let's take a look at the shape of the molecules. That's important. Now, if you have a central atom with surrounded by two atoms, that molecule has two surrounding atoms or lone pairs, that would be linear. Okay, and if you have three, that's going to be a triangle, so we call it trigonoplanar. And if it has a lone pair, if it has only two atoms and a lone pair, we start out with a triangle, but then we end up with another name for it. Okay, and that's band because it has a lone pair. So trigonal planar is the very first one that's come up with. Regardless, it's a lone pair or an atoms, they all the same. Okay, so there's something there, and so on and so forth. So you guys can look it up here. If you got 6 of them, that's going to be octahedral. We're only responsible for up to 4. If you got 4 of them, so X are atoms, but you can also X can also be a lone pair. Okay, so it's always going to start out with tetrahedral, and then if you have a lone pair, then the shape will change a bit. Okay, that's trigonal pyramid. 2 lone pair, bend. Okay, and this table is good. It tells us the angle as well, the bond angle. Okay, that should be good for molecules like CH4. That's going to be 4 surrounding atoms. All right. In the next video, we're going to go over some specific example, some molecules. Okay, thank you everyone, and see you guys soon.